So basically, momentum is a product of mass and velocity. When mass and velocity of an object multiplied, that is known as a momentum. The last topic was conservation of the momentum or law of conservation of momentum. So basically what happened, the total moment in an isolated system, a system which is not affected by external forces, the momentum before collision is equals to momentum after the collision. So if two objects are there, it can be both, like one of the object is stationary and another one is moving. It can be both objects are moving in the same direction with different speed, or it can be two objects are moving in opposite direction. So example, if we have a 2 kg object colliding with 1 kilogram object, which is originally initially at rest, and the 2 kilogram object was moving with 5 meters per second. When they collide with each other, after the collision, their speeds changes. So example, after the collision, the 2 kilogram continue to move in the same direction with a speed of 3 meters per second, and you need the speed of 1 kilogram object. So if we don't know what is the speed of this 1 kilogram object, what we will use? We will use the conservation of the momentum. That the sum of the momentum before collision is equals to momentum after the collision. So momentum before collision is equals to momentum after the collision. Momentum is a product of mass and velocity. So before the collision, the mass of the 2 kilogram, which is moving with 5 meters per second, and the second one is having a mass of 1 kilogram, but it is initially at rest, so 0. Then after the collision, the momentum is the mass is 2 kilogram, but it was moving with a velocity 3, the 2 kilogram, plus the mass is 1 kilogram, and we don't know its velocity, so that's unknown x. So we'll solve this equation. 2 multiplied by 5, that's 10. 0, 2 multiplied by 3, that's equal to 6, plus x. So 6 will move other sides. It will be 10 minus 6 is equals to x, or we will get x is equals to 4 meter per second. That will be the speed at which the 1 kilogram will move. But what will happen, for example, if in a question the two objects are moving in opposite direction before the collision? So you have to, so in that case, what you have to do, you have to consider that the directions, because if one is positive, the other one should be negative. Example, you have say two objects of different masses. So example, a 3 kilogram object is there and 2 kilogram object. And they're moving in opposite direction. So if they're moving in opposite direction, example, if this was moving with 5 meters per second and this is moving with 3 meters per second. So the conservation of the moment, like, so momentum before collision, because one of the velocity, better one which is having a higher momentum take as positive. So 3 multiplied by 5, that will be 15. And 2 multiplied by 3 or 3 multiplied by 2, that's 6. So higher momentum is towards right. So right hand direction I will consider as positive. and the left hand side I'll consider as negative. So basically, what is the initial momentum? The initial momentum is towards right. Why initial momentum is towards right? Because a higher value of the momentum is towards right hand side. So initial momentum is towards right. So when there is a final momentum, the resultant final momentum should also be towards right hand side. So after the collision, the two objects collide with each other. So a 3 kilogram and 2 kilogram. And the question is, for a 3 kilogram object, after the collision, its speed changes to 1.5 meter per second. And the question is, state the direction and speed. So we have to state the direction as well as speed. So first what we will consider, we'll consider a direction example. The direction is towards right hand side. This is our consideration. But if our answer is positive, it means our consideration or our assumption is correct. If answer is negative, it means actually it does not move in the direction which we consider. It move in opposite direction. So again, we will apply the conservation of the momentum. Momentum before collision is equals to momentum after collision. So momentum before, it will be 3 multiplied by 5 plus it will be 2 multiplied by minus 3 equal to momentum after collision. It will be 3 into 1.5 and 2 into x. So 3 multiplied by 5, that's 15. 2 multiplied by 3, that's equal to 6. 3 multiplied by 1.5, so that's equal to 4.5 plus 2x. When we solve, this will be equal to 9 is equals to 4.5 plus 2x. 4.5 move other side, so 9 minus 4.5 is equals to 2x. So this will be 4.5 is equals to 2x, and x will be equal to 4.5 divided by 2. So x is equals to 2.25 meter per second. But you can see our final answer is coming out positive. It means the direction which we assume, this was our assumption to solve this. So direction which we assume is correct. So it is actually moving towards right with a speed of 2.25 meter per second. But if our answer, the final answer is coming out negative, it means the direction which we assume is not correct. Actually, this object move in opposite direction which we assume. Is it clear? This question, example related to conservation of the momentum. Then next topic is about the moment or torque. What is a moment or a torque? Moment or a torque is known as a turning effect of the force. So when force is applied and the object rotate, what we call that as a moment. And how we can calculate the moment? If you want to calculate the moment, moment is equals to force multiplied by perpendicular distance from the pivot. Pivot is a point of rotation. So unit of force, the SI unit of force is Newton and SI unit of distance is meter. So it is Newton meter, and it is a vector quantity. When we say it's a vector quantity, it means that it is having a direction. But what are the directions? Because when object is rotating, it can be anti-clock or it can be clockwise. And the condition, we define a term equilibrium when there is a turning effect. The term equilibrium means when object is at rest or moves with constant speed, what we say that object is in equilibrium. And what are the conditions for object to be in equilibrium? There are two conditions. Number one, there should be no resultant force, and there should be no resultant moment. Or we can say the clockwise moment or the anti-clockwise moment is equals to clockwise moment. These are the two conditions for object to be in equilibrium. So when it is at rest or move with a constant speed, we call object is in equilibrium. And we will check whether when it is in equilibrium, it should fulfill two conditions. Number one, there should be no resultant force. Number two, there should be no resultant moment or turning effect. For example, this is a beam and you pivot or a fulcrum is placed at the center. So weight of the beam, if it's a uniform beams, the weight is acting at the center. So weight is acting at the center, but this weight will not cause any moment. Why this weight will not cause any moment? Because it is acting on the pivot. Because it is acting on the pivot, so the perpendicular distance is zero. So as the perpendicular distance is zero, the net moment, because moment is a product of force and distance, so if this perpendicular distance from the pivot is zero, that will not cause any moment. Then example, two objects are placed of different weights. Weight of this object is 3 Newton and it is placed at a distance of say 2 meters from the pivot. And another object weight is 6 Newton and it is placed at a distance of 1 meter. So because the 6 Newton will cause a clockwise rotation from the pivot and 3 Newton will cause an anti-clockwise. So when we calculate this moment, this will be 3 multiplied by 2, that's equal to 6 Newton meter, which is anti-clockwise. And for the other one, 6 multiplied by 1, that's also 6 Newton meter clockwise. So one is causing a clockwise rotation, another one is causing an anti-clockwise rotation. But because the both moments are same, so when both moments are same, what we call that object is in equilibrium. Example, the weight of the beam is 4 newtons, but weight is not causing any moment because it is acting on the pivot. So it fulfills the second condition that there should be no resultant moment. You can see the clockwise and anti-clockwise moments are same. But what about no resultant force? So how it balances? Basically what happened, a 3 Newton, 4 Newton and 6 Newton are acting down. So total downward force is equals to 13. So what pivot will do to balance this, the pivot will apply an upward force of 13 Newton. So the upward force and downward forces are also equal because a 6 Newton, a 4 Newton and 3 Newton. When you are considering a forces, that case you will consider the weight of the beam that is acting downward. But when you consider the moments, you are not considering the weight of the beam. Why we do not consider the weight of the beam? Because it is acting on the pivot. So when moment is there, if the force is acting on the pivot, we do not consider that it is causing any moment. But when we are checking the condition for that no resultant force, that case we have to consider the force which is acting on the pivot, even though the perpendicular distance is zero. Is it clear, this concept for object to be in equilibrium, the conditions, the definition of equilibrium, the conditions for object to be in equilibrium? then you took this topic in O levels, but now a small change will be there. You will find a question, very common question, in which you have two axes of rotations or 2 point of rotations or two pivots. Now, how to solve a question in which you have two axes of the rotations or two pivots? Example A is there. You have to check in a question. Sometimes they mention the weight of the beam is negligible. So you can, when it's a question, it is mentioned that weight of the beam is negligible. That time you will neglect the weight. But if they say weight of the beam is having a specific value and it's a uniform, so it should act at the center. So weight of the beam is 5 Newton. Or if I say uniform beam is equals to the 5 Newton. And the object is also placed. So if it's a uniform beam, the weight should act at the center. So this 5 Newton is acting at the center. The length of this beam, say it's 6 meters. And distance from each end is equals to, like distance of the pivots is equals to 2 meters. Then an object is there which is placed 2 meters away from end. So this is end X, the other one is end Y. An object is there which is placed 2 meters away from end Y. The question is, calculate this weight of the object is there. Weight of the object is example 20 newtons. So if a question is there, calculate the force exerted by pivot A and the force exerted by pivot B. That is the question. So now in this question, you have two pivots. So first, what you will do, it's up to you. You can consider one of them as a fixed pivot or the point of rotation, and other one you will consider that force can cause a rotation. So it's up to you. You can solve by considering A as a fixed pivot, or you can consider B as a fixed pivot. So example, if I consider this 20 Newton is also acting down. Example, and this beam is at equilibrium. So you will consider, it's up to you. You will get the same answer. Example, I consider A as a pivot or the point of rotation. So if I consider A as a pivot or A as a point of rotation, so I will apply the conditions of equilibrium. As it in equilibrium, so anti-clockwise moment is equals to clockwise moment. So there is no net resultant turning effect and the clockwise and anti-clockwise moment. And I consider A as my fixed pivot or the point of rotation. So now I consider first thing, the force which is like force exerted by pivot A on the beam will not cause any moment. Why it will not cause any moment? Because it is having a perpendicular distance 0. So this 5 Newton, which direction will cause a moment? It will cause a clockwise. This 20 Newton, which direction it cause a moment? Clockwise. And this FB, the force from pivot B, which direction it cause a moment? It will cause an anti-clockwise moment. So these two are causing a clockwise moment. The force of the B is causing anti-clockwise moment. So the clockwise and anti-clockwise moments are same as it is in equilibrium. So we always take distance from the pivot. So the anti-clockwise moment, that is force. So that is force of the pivot B multiply by distance. What is the distance? We always take distance from the pivot. So if I consider A as my pivot, so what is the distance between A and B? If the total is 6 meter long, example, this is 1 meter, this is also 1 meter. So 1 meter is a distance of A from X and 1 meter is a distance of B from Y. So because the total is 6, so the distance between them will be 4 meters. So this will be 4 equal to clockwise moment. So 5 is a force multiply by distance because it is acting on at the center. So if it is acting at the center, it's a uniform, because the term uniform means it's acting at the center. So if this total will be 3 meter, if distance of the pivot from the end X is 1 meter, so what will be the distance of this force? That will be equal to 2 meters. So 5 is a force multiplied by distance is equals to 2. Plus, there's another force which is also causing a clockwise moment. So 20 is a force multiplied by distance from the pivot. So from one end, it's 2 meter from end Y. So remaining will be 4 meter, but out of that 1 meter is this. So we are left with look, what will be the distance? How we can work out this distance? This 20 Newton is 2 meter from end Y. So if it is 2 meter from end Y, so remaining it will be 4 meter from end X. But we don't need the distance from X, we need a distance from pivot, and X and pivot are 1 meter. So what is this distance? That distance will be 3 meters. So just we will solve this. Is it clear how we worked out the distances? So 5 multiplied by 2, that's equal to 10. 20 multiplied by 3, that's equal to 60. So FB multiplied by 4, 10 plus 60, that's equal to 70, and 70 divided by 4. So 70 divided by 4. That's equal to 17.5 Newton. So 17.5 Newton is a force by B, but we need a force by A as well. So for that purpose, what we will use a condition that upward force equal to downward force, or there is no resultant force. So upward force equal to downward force, or there is no resultant force. So what is the upward force? There is an upward force from A, the pivot A, that's FA. And there is an upward force from B, that's FB, is equals to the downward force. So what are the downward force? 5 Newton is acting down and 20 Newton is also acting down. FB already we know it's 17.5. So FA plus 17.5 is equals to 25. 17.5 move other side. So FA is equals to 25 minus 17.5. What's the final answer? So it will be 2.5 plus 5. So it will be 7.5. So 7.5 Newton is force from FA. Is it clear this example? So when in a question you will find there are two pivots. So in that case, what you will consider, you will always consider that one of them is fixed and the other one is causing a rotation. Is it clear this example? I will share the assignment exercise related to moment as well, so you can go through. Now, free body force diagram. What is a free body force diagram? Actually, free body force diagram, it represent all the forces acting on the object the direction of the force is represented by arrows, and the magnitude of the force, the magnitude means value, is represented by length of the arrow. Like if it is higher, greater magnitude, we'll draw a longer arrow. If it is smaller magnitude, we'll draw a shorter arrow. So free body force diagram basically represent all of the forces acting on the object. Example, an object is on the horizontal surface. So if I want to draw the free body force diagram, so the weight will act downward, and because the surface will apply an upward force, and that force is known as the normal contact force. And this normal contact force acting up, and because this object is not moving or it is stationary, in that case, if object is stationary at rest, so there is no horizontal forces or forces, like resultant force is zero. So this object is at rest. But if another object is moving with a constant speed on horizontal surface, so how we represent, if for example this object is moving on the horizontal surface with a constant speed, and we want to represent a free body force diagram, so weight acting down, the normal contact force is acting up, then the force which cause a movement, example is towards right, and the friction is opposing the motion is toward left, but the length of the arrow should be same, which shows the magnet, like the weight, the normal contact force or the reaction force, the force which cause a motion towards right, example, and the frictional force is towards left. And if this object was accelerating on the horizontal plane, how we represent the free body force diagram for this object, say it is accelerating towards right hand side. So in that case, the force which is causing a motion is higher as compared to force which is opposing the motion. the weight is acting down. So horizontal plane, there's a resultant force. Vertical plane, there is no resultant force. So in that case, weight and normal contact force should have the same length, but the force which is causing a motion is more than the force which is opposing the motion. So this object is actually accelerating towards right hand side. Is it clear? If in the question they mention there is a air resistance, then you will consider. Otherwise, the friction, what you are saying, a friction force, it is also including the air resistance. Then on inclined surface, so when object is on inclined surface means a surface which is making certain angle with the x-axis, that's known as an inclined surface. So say there's an object which is placed on the inclined surface, and it can be at rest. Example, the object is at rest. So what are the forces acting? The weight, which is always perpendicular, means acting downward, that's weight. So say this is a weight which is acting down, and the normal contact force is always perpendicular to the surface. So what is the normal contact force? The normal contact force is, but how this object is able to or remain at rest? So actually what happened, the friction, this is a friction which is opposing its motion, because it tend to slide down, but the friction is opposing its motion. This is a normal contact force, R you can say. The force actually, like as you can see how the forces are balancing, like how the friction is balanced as this object is at rest, and how the normal contact force is balanced. So basically when we, this is a free body force diagram, but if we divide this into components, like if we take the axis here, so this is our y-axis, this will be x-axis. The angle which is the inclined surface is forming with x-axis is always same as the angle with the weight is forming with the y-axis on inclined surface. So according to this, the weight will have component, the component of a weight which is with an angle, that's w cos theta, and against the angle, that will be w sin theta. So as it is at rest, it is not moving. So what does it mean? It means that w cos theta so actually what happened, the w cos theta is equals to r, and w sin theta is equals to f. But if this object was accelerating, so if this object was accelerating downward, in that, if it is accelerating downward, it means the force, the downward force, like this was stationary in the first case, but if it was accelerating down, then what happened? It means the w sin theta is more than the friction. So in that, but horizontal, vertical plane, there is no acceleration. So again, the w cos theta will be equal to r. But what about the inclined plane? In that it is accelerating, and so w sin theta, we have the Newton formula, F is equals to ma. So resultant force which is causing an acceleration, w sin theta minus friction is equals to ma. If we neglect the friction, like if friction is negligible, so if friction is neglected, if we neglect the friction will be zero. So what we can say, w sin theta is equals to ma. And what is w? W is equals to mg. So in place of W, we can write mg. So we can say mg sine theta is equals to ma. This m will cancel with m. So on inclined surface, if friction is neglected, the acceleration on inclined surface is equals to g sine theta. So this is a formula. If a question they ask, calculate the acceleration of object on inclined surface. So what you need, you only need the angle which the inclined surface is making with x-axis and just multiplied by acceleration due to gravity. So you will get it, or you will know its acceleration. Is it clear? But this is only valid if friction is neglected. If friction is there, in that case, it is not equal to g sine theta. Is this clear? When object is at rest, then horizontal and vertical component both are same. But if object is not at rest, it is accelerating down. In that case, A is equals to G sine theta. Any doubt in this part?